Yeah, now as we were continuing, we have just finished making the subject of the formula. Then we are going to factorization, which is our third subtopic. Then lastly we shall solve those equations. So let us right away go into factorization here. Factorization, and in factorization we shall also look at several things here. That means the subtopic of a subtopic again. We shall look at simple factorizations. Then we shall also see four-term expressions. We shall visit the difference of two squares. Then lastly we shall look at three-term expressions, which we are going to call trinomials. Three-term expressions, which we are calling trinomials. So when we finish that, we shall right away go into some special equations called the quadratic equations, and that will be the end. So I hope you are very, very attentive as we started. Since we started, are you attentive since we started the first subtopic up to now? That's wonderful. Now, to factorize is to remove a common factor, and that common factor must be the highest common factor. So, removing the highest common factor is what we are calling to factorize. See, highest or greatest. See, like if I said, what is the greatest common factor between 2 and 4? 2 is the greatest, so we can have it as 2 out. Then in the let me use this as 6. Will 2 be still holding? Yes. So this will be 3 plus 2. In here, 2 times the 3 is 6, and 2 times 2 is 4. So when you remove it, must be such that the term out creates back at the original expression. See? Let us start with simple factorization. To factorize, see, is to remove the highest common factor. So there we go. Simple factorizations. Okay, factorize each of the following. Factorize each of, there is a Z not S, zation, each of the following. See, the following. A, shall look at 4A plus 6B. See, 4A plus 6B. What do you think is common there? In 4, there is a 2 times 2, not so? Yes. In 6, there is 2 times 3. So these 2 and these 2 are common. That will mean we should obtain the 2 out. So I remain with a 2 and an A. Of course, there is times A, there is times B. You see, I've only circled this and that, so I remain with 2 and A, then 3 and B, so plus 3B. I will have factorized. So, yeah. We are continuing. 2x squared plus 4x. So, see, this is what? In breaking down, it will be 2 times x plus 2 times 2 times x. Who is common? 2 and x. 2 and x. So I remain with I have 2x. X plus 2. Okay, now let me dig into this. That is 3x squared y. 3x squared y plus 6xy. Then plus 27x squared y cubed. See, what's common here? Now, the process of breaking it down is tiresome. That means we shall use mental work. 6 contains 3 times 2. 27 has
3 times
3 or 3 times 9.
Yes.
So, 3 is common. Clear? What else is common? There is x and y. See? That means I will have 3x y into
x squared.
X squared.
No.
See? 1x is out, they were 2. So you remain with x plus, see? Here I've removed the 3, there is a 2. And xy is out, plus 9. 1x is out, so x, not so? And 1y is out, so you remain with?
Y squared.
See? Yeah, so now I'm again bringing in these 2. I hope people are enjoying their factor. See, 2p out of t squared, 2p squared. See, this is squared, this is cubed, plus 6p cubed out of t squared, t cubed. So, what is what do you see a numerator and
Denominator.
That's exactly. So there is a 2 times 2, not so. How many p's are here?
2.
What of here?
3.
What of here?
3.
So what is the commonest p? 2 p's. Why not 3?
Because on one side there are only 2.
On one side there are only the highest to be there is the p squared. The highest to appear in all is the p squared. So here, is there another factor?
No.
There is a what?
2.
2, therefore I have 2p squared out of what's commonly down? T or t squared?
T.
See? T. That's right. That's right. That's right. Into what? Into what remained here? 2? 2p? 2p?
No.
Nope. Minus p what? P squared is out. How many p's are these?
1.
See, therefore remain there what? 1 of them, because these are 3 of them, 2 are out. So you remain with? Say only 1. How many t's remain here? 1 plus, say,
3 p out of t squared.
Wonderful.
Excuse.
You are very, very much.
Does that mean the number outside affects all the fractions?
Does it mean this number affects all?
Like what I'm trying to say, that p squared, why is it that we use it for all the fractions?
See, because there is one bracket on all. So it is for all. You believe that? See. That's right, that's right. Okay. Now there you go into a broad one here. So you see, this math is very, very, the ancient fathers of math really did work. Do you accept that they did work?
Yes, they did.
You do not accept there is some head that does not believe that the ancient fathers did for us. How many people are warming up for their numbers? Because no sooner had I done this than I gave you some. No sooner had I done this than I gave you. See, what is appearing common? Let's take first item, 8 and 4. 2. Who is the most to be common? 4. 4 or 2? 2. Assuming we took away 2, we remain with the 2 and the 4. They will still have. So if you took away 2, you remain with a 4, not so? Here you remain with a 2, but a 2 will still be common between 2 and 4. So you take the smallest value between them if it's divisible.
But teacher,
no. Between 8 and 4. Who is small? 8, 4. See? If it was a 6, you would not take 6, of course. 6 can't be totally divisible by. See? Or you rather go aside and find the highest what? By 2? 4. By 2?
1.
This has divided fully, not so?
Yes.
Even this divides fully? Yes. Does this divide fully? No. It only divides here, so this is the highest. So there is a 4 first, but who is again common between them? All of them. This, say the other bracket. Of course, the outside things, AB is not common here, not so?
Yes.
But this one is common, so put it out. A plus B plus C. So who remains inside in the first place? 2. Who remains here? See? So that's it throws me into this number, though I had made a promise, but promises can be withheld. So it throws me into this that will initiate me into your question. So use factors to evaluate, evaluate. Use timeless. 793 plus 786 times 793. Yes.
you repeat for the last number. I've not understood.
We wrote.
You repeat for explain it.
We repeat the last number here.
Yes.
Who has understood it that may help me? You want to help me?
Yes.
I've also not understood it, so come and help us. See.
And I can explain.
You can explain from there. Go ahead.
Okay, teacher says that we shall look for the lowest number among those ones. We have 8 and 4.
8 and 4.
So we shall have to take 4. But if it was
take 4.
6 and 8 can be divided. So we had to use...
What is this 4 called?
Highest common factor.
Highest common factor between 8 and... There I gave a layman's way to pick a highest is to pick the smaller number which is divisible totally by the bigger one. So
after that we were looking for what is common in both. We saw that bracket of A.
This bracket and this bracket is here and here.
Yes.
Okay, what's confusing is that assuming that bracket we called it X. If this was X, what would you put out? Of course, you'd put out a 4 and X, not so? So what would remain? 2 minus AB. See, if this X is the big bracket here, well, the size should not confuse you. What's confusing you is if we replace this by a smaller number, you would easily see. That's why when they take you to the garden to dig, you first look at the size and you fear. Yes?
Check, I'm not getting.
What you aren't getting is 8x minus 4ax. What are you not getting?
The 2 on the answer.
This is 2. Why is she not getting this 2?
Okay, you get that 2 after multiplying 2 times 4 to give you 8.
Should we, are you meaning that this is that?
Yes.
Then this one is 2 times A times B times X.
Yeah, but I thought it was.
No, remove now. Remove who is common. This is how many 2's?
2 2's.
So you would remove this 2, this 2, this 2, this 2. That's 4. This X, this X. Who remains here?
I thought it was wrong. It's okay.
She had the thinking that it was incorrect, but it is okay, not so? Okay, now we are here. Who is common here that we can remove out?
7.
Don't use the calculator, you do get 0, 0. You have what? 7, 9 what? So, who remains here?
617
times 0 or 1?
0.
Should I put here 0 in this place or 1?
1. Yes.
Because something itself is one of that thing. Do you believe that?
Yes.
See, times 1 plus 5, 9, 7 times.
1.
So here we shall get 6, 1, 7 plus 7, 8, 6 plus 5, 9, 7. Add it mechanically or by a calculator.
$2,000.
2,000 multiply. Okay.
1,586,000.
Okay. Now I prepare you. Come on.
Excuse me.
Yeah, excuse me, very, very highly.
So what if you don't include that in times 1
And you just write this.
Yes.
There is no query. Factorize complete. Oh, so only we are putting only 2 and the a b into 2 minus c plus 6 ab into 2 minus c. So we can request for somebody to handle that. Then then on number 2, let me put here also number 2. Without using a calculator. That means use factors, evaluate 21.35 times 41.35 minus 21.35 squared out of 0.02. Can I receive 2 people there? Yes, come on.
Let's find this first one. Factorize completely 3ab into brackets 2 minus c plus 6ab into brackets 2 minus c. Remember, this and this, they are all in ab, and the highest common factor of those two, it is 3, since 3 can be divisible by 6. So we shall have to write 3 ab, since they are both in ab, into brackets 2 minus c, since they are all 2 minus c. Then the remaining thing this side is 2, since when we multiply 2 times 3, which is the highest common factor, we get 6. So plus 2, yes, since ab is already this side, so we shall not add ab this side.
Somebody has things you should give different. Okay, come on and we see. Thank you, Precious.
For me, I think here, since we have 3ab into brackets 2 minus c plus 6ab into brackets 2 minus c, so I think here the HCF, the highest common factor of 3 and 6 is 3, so we shall have 3. Remember, this is 3 times 1, this is 3 times 2, so meaning here we shall have 3. Remember, AB is the same, so we shall also have here AB, and remember also they have this 2 minus c the same, so we shall have 2 minus c. Then you open the other bracket of the remaining things, so here we are remaining with 1, so it will be 1 plus 2.
Why are you giving a different approach from hers?
Because here she never determined this 2 minus c to be the same. She included this 2 within this very same bracket.
I think I've detected that I also had an error. The setting, one person should have that, because this is like adding like a terms. It would be 9, because this will be 3 times 3, which is 9. So there was a default here. Thank you very much. You have been very well. So this would be added directly. It would be 9ab into, it would just be 9ab into 2 minus c, which is the same here. 3 times 3 would give 9. So there was just an error in the setting. I expected to put, I think this should not have been here, so that you would have remained with what? 2, here would have remained with a plus 2. Yeah. Okay, let's have somebody help us here. Mira, are you taking on this?
Here we are going to get the common number, and here the common number the common number here which I can see is 21.35. Minus 21.35 divided by this 0.02. So we shall multiply this 21.35 with all the numbers in the brackets. 0.35 times 4.
Keep time.
Minus 21.35 times 21.35 equals to divided by this 0.02. Equals to 0.45 divided by 0.02.
I see, captured it down well. Yeah, thank you. I see use the factors. Thank you very much. She factorized out well. Not so. But this does not indicate factors. That means this step she brought in a heavy calculator. Not so. So you must demonstrate to the highest level that you use the head. Okay, subtract here. What do you get? That's roughly 10. It is 10. Not so? 20. 20, not so? Yes. Out of 0.02. So that's how we will move, not so? Then we can have this one, 21.35, or we remove a decimal and express out of 100 times 20 divided by 2 out of, you agree this is total 100?
Yes.
So 21.35 a 1,000, 10 will go, not so?
Yes.
So times 2, times 100 out of 2. Not so? I'm not using a calculator.
Then 0.
It will go not so?
Yes.
Which is 2135.
0.
Okay, thank you. Let's drop to 4-term expressions. Factorizing 4-term expressions. Factorizing 4-term expressions. Method is that first group them into two what? Groups. Either by addition or subtraction, depending on what will be easier for you to work with the positive and negative signs. So I hope people have understood. When they say don't use a calculator, don't demonstrate a calculator. Now that here we factorize them by what? By conducting what we call a group work. Factorize each. Because there is a lot that we have to close down, so okay, when they say factorize 4 terms, we group into 2 groups. Then in each group we remove what's common. So here, this is first group, we shall group also the other one. So I will have AB minus 3B group plus 3C minus AC group. Who is common here? B. B into
A minus 3.
A minus 3. Then plus here, who is common?
C.
C into
3 minus A.
3 minus A. Now, in handling 4 terms, the formed brackets should have similar items. This bracket is the same as this, but they differ by a negative. So endeavor that in handling 4 terms, always make sure this term looks similar to that. So how will I play that? See, A is negative here while A is positive here, so I'll remove a negative from here. Or you remove a negative from here, anyway it will work. See? Now, how do we do that mathematically thinking? Put a negative out. See? If a negative is put out, how do you maintain the value to be positive on opening back? 3 becomes? It's like when you put a negative out, you just change signs on both. Because if you try to open it back, it will give us a positive. See, when you factor out a negative, change the signs on the items inside. Because the negative has the tendency to change the signs. So keep note that point is going to be conducted throughout my factorization up to where I will end today. That when you remove out a negative, in trying to modify terms, change the signs. See? Change the signs. So rearrange this in order now according to the way it should look. Now negative positive will become clear? Yes. Into A minus. This is just rearranging. There is a negative, A is a positive. Who is common now? See? A minus 3 is common into. Who remains here? B minus C. So you will have I hope your head is okay. So endeavor to know how to modify signs. A negative modifies signs. See? So a positive can't affect signs. It's a negative that affects. That's exactly. Now let's group. We said 4 terms group. Now listen. You must group in a way that what we are putting together shares a common. See, we would even have grouped this with that. It would still yield this. Or this with that, because this share 3. See? Now I'm showing you that sometimes we might disorganize the expression, and I can put this where I put plus 3c, then minus 3 what? Then you must collect, here there is nothing common, you must bring this together. See? So that's right. So is there anything common here and here? Yes. Yeah, so they are okay to be grouped. Now I want you to pay attention here. I've said when you dare to put a negative out here, it will change the. Listen, if you use a negative, if you factor out a negative inside, it will change their signs. So 3 will become what? It is negative. It will become positive. Then this one will become, see, if you use a positive here, you maintain what they are. See, that's right. See, I'm going to use both. That's right. See, AB minus 3B out. I'm using a positive first. Into. I maintain their signs. See, negative 3C plus A. See, a positive has nothing to do with the signs. Positive times anything, that thing remains as it is. See, who is common now? So, who is common? B into A minus 3 plus who is common? C into negative 3 plus A. Rearrange this. We say this must look the same. So I think this is A minus 3. Not so? Yes. This A minus 3 because A still is positive and 3 still what? Negative 2 plus 3 is the same as 3 minus 2. Yeah, now there you are growing mathematically. So these are the deep things, the very deep things that you must keep at your attention. So okay, who is common? That is A minus 3 into what? B plus. So alternatively now let's put a negative here. Now we've said when you put a negative you must change their signs. It's not changing the signs, but if you open the back they return. So see, this will now become the positive minus AC. If you try to open, it will go back. That's right. So that's now B into A minus 3. Now here who is common? C into 3 minus A. But look, these are differing by again a sign. So modify this by, now you see this is negative 3, this is positive 3, this is positive A, this is negative A. So enter the negative in, say outside put what? So see It is entered inside now. Plus A. See, that's right. That's right. That's right. But one is more brain demanding than the other. Ooh, let me do one more, then I give you some 2 and we really see. See? Yeah. Should I do one more? I do one more, no? Not so? And also prepare for, remember that we are keeping time. As I'm keeping time, you keep the time. See, 12k squared L minus 2kl cubed. I want to be careful because when I copy an error, it will not be factorizable. Plus 3l to power 4. So, there we are, we go. We again factorize it. Group now. Is anything common first? Yeah. So, 12k squared L minus 2kl cubed the group. Should I use plus or minus? Plus. See, 18kl squared plus 3l to power 4. So, who is common here?
6. I mean 2.
2 is common. So 2 with who? K and
L squared.
L squared. There is one L here. So I take only one L, the smallest. So I remain with 6k minus L squared. Then plus, who is common? 3 is also in 18 by 6. So 3. Is k common? Nope. L?
Yes.
L squared. So? Negative 6. K?
Plus 3L
Squared. That's right. That's right. No, not 3. Yeah. See, is this the same but differing in sign? The difference is the sign, not so? So, what do? L squared. Put out a what? So, negative 3L squared. Who remains? Positive. Then here? We said change the signs no sooner. See, change the signs. So, we can just directly remove now. Okay, let me modify that part. Negative times a positive is a negative, not so 3L squared into 6L. Of course, you can just from this step go here and avoid these 2 repetitions. So, who is common? Now see, who is common between here? L. L and 6k minus that. So, this is common and this is common, of course. 2K. And L, this is 2k minus
3L.
See, I hope the head won't crack. So. Who is coming? There are 2. Who is coming? Ah, that's right. Who is on the cam? All of you. See, TV plus 3uv minus t squared minus 3ut. See, now now we are calling in now for me, I'm putting there tricky ones that need this. I will not put there simple ones. See, 3mp. See, mp minus 9mq. Then minus 3nq plus np. Are you ready? Walk forward, walk forward. Thank you for being courageous.
I'm working out this one. We have TV plus 3uv minus t squared minus 3ut. So here we shall group them. We shall have TV plus 3uv plus, so we shall keep the signs because it's a positive here, it's an addition, negative t squared minus 3ut. So here we have common members like v and v. So v into t plus 3u plus, here we have common members like t and t. So here we shall have t into negative t. Here we shall remain with t minus 3u. So here we shall have v into brackets t plus 3u plus, since we want to make this one a positive and make this the same, so we shall have here negative t, so this will turn into a positive plus 3u. So v so a positive times a negative gives us a negative. So here we shall have minus t into brackets t plus 3u. So we have here common members. We have t plus 3u as the common member in both sides. So here we shall have t plus 3u v minus t.
Yeah, thank you, Grace. You have been very, very fabulous. That's being very, very, very good. Yeah, step one. Yeah, she has been very, very, very fabulous. So she's you come on and take over. I'm not seeing you. one person participating. See, I thank you for being very, very courageous.
So 3mp minus 9mq minus 3nq plus np. So we shall have to first put them in brackets. 3mp minus 9mq negative 3nq plus np. So we shall have to find the highest common factors in, the common factors in both the brackets. So here we have 3 times 1, we have also m and m, then here we have 3 times 3. So we shall select 1, 3 and even 3 from this side. So 3 and m into brackets p minus 3q into brackets plus, we shall have to first find the common factors in this. So we have n and n. So n into brackets negative 3q, since it's done, that remains, plus p, which also remains. So we have to make this a positive. There is no need for making it a positive, since this side it's a negative and this side it's also a negative. So p this side is a positive and also p this side is a positive. So m, we shall say p, which are the same here and here, they are all positives, p minus 3q, since they are all negatives, and then 3m plus n.
Yeah, this girl has been very, very incredible. Could you imagine this interpretation? That she needed not write the second step, that this is the same as that. See, because this is the same as that, she just went direct here. That's incredible. That's incredible interpretation. So, oh, she's very, very incredible. Yeah. Now, I love that so much. Now let's go to this other version here. See, this other version called the difference of two square factorization. Before, that means difference of two square. I want this is called kind of an identity, a general expression that cannot change. Yeah, now you can really see that. See, now look here. There is this saying here. This is called the difference of two what? You see that word difference means subtraction. You are subtracting two squares, two squared terms. See, now the inventor realized that it is the same as this. What does that mean? It It means if I have my 4 squared minus maybe 2 squared. He said don't waste time to bother with the heavy calculator. He said in the first bracket add, then in the second bracket sub what? Subtract. So it will give us 6 times 2, which is 12, which you can test. 4 squared is 16. This 2 squared is, on subtraction you get. So when one term is squared and another is squared, the factorization form is that first bracket add, second bracket sub. Now we are now, I hope people are warming up with numbers. See, Miller, you have not been very participate. You have not been partisan. No, you were partisan once. Then there is one person who was not partisan. See, okay. Examples here. Factorize each. Say, factorize each completely. The word completely means go on and go on until there is no more common what? See, common factor. X squared minus 9. Oh, so we use the concept of the difference of 2 squares. Now when you see one term is squared and the other is not, you make sure it is also squared. So x squared minus 9 will become what squared? 3 squared. Not so? Yes. So the interpretation is that first bracket add, second bracket sub, and you'll have factor. Yeah, that's it. So that's it. 64. How can we arrange this? You see that this 81 can be who squared? 81 is who? 81 is 9
squared.
9 squared, a squared, not so? Yeah. Minus 64 is 8 squared, b squared. So since both have a square, you can put them under one. Is that very clear? Yes. So in one bracket add them, 9a plus 8b. In the other bracket sub. See, whether you start with subtracting them first, see, the thing is the same. Whether you say minus first then plus later. So
when they say factorizing completely, so meaning if you have reached that step, you end there, or you have to use that for expression?
Because there is no, we have to use the 4 term in case there was again more common things. See, do you understand? But they are no longer common. Is there anything common between 9 and 8? No. So, but if it happens to come there, we proceed and what?
Establish your class one example where we can proceed.
You guys, math is endless. As long as the brain can think, that means the numbers can exist. Oh, that's right. 27 minus 12, 27b squared minus 12. Let's try to examine this. We shall call in your number that you're asking for. We shall call it here. See, I'll call it and it will come. So, before you tamper with this, is anything common first? You see, don't tamper first, check first. Before I tamper, is there a factor here first? 3. First put it out. 3. Who remains here? See? 9. 9b squared. Who remains here? 4. That's right. So you can have 3 squared b squared minus 2 squared. Clear?
Yes.
3b, see, minus 2 squared. So this is a difference of 2 hot. Because this is one single item. So what will you have? Say 3. One bracket add, the other bracket sub. Oh.
Just one meaning the one outside the bracket shouldn't multiply
It only multiplies once, because when you are using multiplication, can you multiply twice? 3 times 2 times 4. Can you say 3 times 2 times 3 times 4? Nope. It multiplies once. 3 times 2 is 6 times 4, 27. I mean times 4, 24. But you cannot say 3 times 2, 6, then 3 times 4. That would be really new mathematics. So it would be new. So it would be very, very new that you wouldn't accept. So So that throws me into 2 numbers here. Your sister asked something, but we can still first proceed on before we can look at her askings. Yeah, we can look at her askings later. So later. Factorize. We are still proceeding. Maybe somebody would guide me here. Minus. Who is going to guide me here? 6x plus 2y. How do I factorize that? Up there. Let's first handle up. What is up here? This is 3 squared. Not so?
Yes.
X squared minus y squared. Out of who is common here? 2 into 3x plus y. Up is the difference of 2 squares. Do you see that?
Yes.
That is 3x squared minus y squared. So what do you have? What do you have? One bracket add and one bracket subtract out of 3x plus y. So this will die. 3x minus y out of 2. So
So I was going to ask that in case you get a number that can be divided by 2.
you do what?
But still that 2 is out of all the numbers, including 1.
It will only be expressed out of each. Oh, without... Now your sister asked a question there. We want to put it for her. Then we call in somebody to show it with see. Yeah, she asked this. 4x squared. Maybe the one who asked, we shall ask her to help us when we have given her what she wanted. We shall ask her to help us in the next one. Now, see, these are 4 terms, aren't they?
They are.
See, that means we first tamper with the group. See, so 4xy squared minus x cubed. Let me hope these have a common thing first.
Yes.
See, that's right. Plus
yx squared.
yx squared plus
4y
cubed. Group, not so?
Yes.
So, did I really... No, there is a minus here, sorry. There is a minus there. What can I do?
Plus negative x.
I maintain the negative inside.
Yes.
So, clear. See, what's common?
X.
X. Not so?
Yes.
So I remain with
4y
4y squared minus x squared. See, plus, who is common?
y
Y into
x squared
negative x squared plus 4y squared. So this can be written in a proper way. Clear?
Yes.
So plus y into 4y squared minus x who?
Squared.
So again you see who is seeing something here. Is that very correct?
Yes.
This is squared on 4 is that correct?
Yes.
So will be the same here. See, 2y squared minus x squared. Okay, let me first remove this because it's common first before I tamper with the further work. So what will I have? 2y squared minus x squared into
X plus y.
x plus y. So break these. We add and we subtract. So that's right. That's right. That's right. No, I will not hesitate to check her before I go to another so how many will use the shortest 2 minutes only without using a calculator? Evaluate 68.75 minus 31.25 out of 3.75. What can I do here without a calc? The same concept. Difference of 2 what? 2 squares. So I will have 1 bracket add, not so?
Yes.
Then 1 bracket sub. subtract somebody who is doing some mathematics there over 3.75. This is what is this? So that 100, because 5 plus 5 is 10, carry 1, 7 plus 2 plus 1, it's 100, yeah. Next one is that is 37.
5.
Like that.
Yes.
We are dividing by 3.75. Not so?
Yes.
So this time on 375 out of 10. See, one decimal place. Then divide by 375 out of 100. Clear?
Yes.
This would go clear.
Yes.
So 375 times 100 out of 375, giving us 1,000. Wonderful. Wonderful. So, try, factorize. Who is very, very willing here? Who is very, very willing? Make sure you are using only 1.5 minutes here. So, then somebody come and also use 1.5 minutes here. 2p squared q cubed minus pq cubed plus pq minus 2p squared q. Could I have somebody running here? Very fast. Don't think many thoughts. Do not think many thoughts. So many thoughts.
Okay, here we have x cubed minus 9x y squared. So we shall have to first find out the common member in both numbers. Here we have x cubed. Here we have xy squared. So the common member is x. Here we shall remain with x squared minus 9. Okay, 9 is simply 3 squared, but remember this x is gone, so we shall remain with y squared. So after this, we shall have x into x plus 3y minus x minus 3y.
Thank you very, very much. Yeah, it's really very, very motivating. So wonderful work. Wonderful, but there is a doubt. What do you doubt like me? What's wrong with your expression inside? See, a squared minus that means a plus that, a minus that.
I shouldn't have put that minus.
See, this one you try it in your free time. So it throws me into three terms which are called trinomials. Yeah, that so let me remove this. We go to three terms or trinomials. Trinomials. So three-term expression. So, the word try means what? Three. See, yeah, now you need to be real attention here. So you need to be real what? Attention. Now, a trinomial is a quadratic expression of the form, see, ax squared plus bx plus c. C, e.g. So, now you need to listen. 5x squared plus 2x plus 3. Now look here. That the one we are talking about is not this. We are not saying factorize this. Plus 8. This is not what we are talking about. Here you would simply remove the common factor as 2. Not so? Yes. We are not talking about this. See? We are talking about a quadratic expression. Now, sir, what's a quadratic expression? Is that expression where you have x squared somewhere, and also you have x, and also have a term without x. So, oh, that's right. You have x squared, you have x, you have a term without x. But sometimes you can have without x, but as long as there is an x squared, see, it qualifies to be a quadratic what? Expression. I've given an example here. Does it seem to confuse you? Give me one maybe. Can you read for me one of your choice? Which quadratic expression will you give me? 8x squared
plus 4x plus
2. Yeah, that's a quadratic one, but again there is something shared here commonly. Normally it is.
It's automatically meant to be only x, not any other letter.
It can be y, it can be, for example, it can be y squared plus 2y plus 1, etc. Any letter. Oh, now you must know this. Now the method of factorizing this involves identifying the product of the expression and the sum of the expression. Now note that a quadratic expression contains what the part called the product and the part called the what? The sum. So we shall explain that in depth. See, now look here, e.g. let me pick one here. 5x squared plus 2x plus 3. See? Now look. This here, the neighbor of x, the coefficient of x. The word coefficient, we saw it in senior one with the neighboring number to x is called the what? See, so when I say what is the sum there, you just pick the neighbor of x. Then the product is a product, we multiply this and the term on x squared and the term on without x. So the sum is 2, then the product, say, is 5 times 3, giving us 15. Oh.
Sorry for going behind, but is it possible for them to bring maybe x squared plus maybe another a different letter?
No. That one you look at it in senior 3, where we call it simultaneous equations.
Teacher, can 5x, where there is 5x squared, can 5 be the sum?
Nope. It is the neighbor of x, not x squared. See. Oh, that's exactly. See. Could you give me the sum here? What is the sum and product in each? See, class, we have not started to factorize them, have we? No. What is the sum here? Not the product. Let me see hands up. 6x minus 1. What is the sum and what is the product? So, for minus x minus 5x squared, the sum, then the product. Let me see, class, we are here. What is the sum here?
2.
2. What is the product?
1.
The coefficient of this, not so, times this.
1.
This is 1. 1y squared times 1 is 1, not so? See, out of here, what is the sum here?
6.
6, see? Why is it negative 6? See, the neighbor, the coefficients. So the product is this hidden 1 times this. So the product is negative 1. So disorganized. So what is the sum?
4. 1.
That's exactly. That's right. Is it 1 negative 1?
Negative 1.
Then the product we multiply, say 4
Times
negative. Now look here, class. There is, now we are going deeper until we enter into factor. See. Now there is this part called determining. Now we are going into next part that again there is another thing on this quadratic expression, that after identifying the sum and the product, there is always two numbers. There is always two numbers which when you multiply you will get negative 20, and when you add them you get negative 1. Now I want the heads now, the heads to be really attentive here. Now pairs of numbers which we call factors. See, that give the sum and the product. I want brainy think tanks. See, brainy think tanks. Pressure, are you still thinking very, very properly? So now, see, find two numbers which when added give the sum, and when multiplied, see, when multiplied give the what. So now you see the first thing is x squared plus 5x plus 6. Now let me see. What is our sum there? What's our sum? 5. What's our product?
6.
What have we multiplied?
1
Gives us 6. Now, can somebody pick for me two numbers? If you multiply them, you get 6, but if you add, you get 5. See?
3.
That is 2 and
3.
there you are. So this is a pair I'm talking about. Now let me grow into depth. See, let me say this. 5x squared plus x minus 6. What is the sum here? Product, then the pair?
1. Sum.
The sum is?
1.
Product?
Negative 30.
That's 5 times negative 30. So, oh, there you are. Which two numbers, when you multiply, you get negative 30, but when you add, you get 1. See, again I'm seeing one hand there. Which two numbers, if you multiply them, you get negative 30, but if you add them, you get 1. Yes, Patience? 5 and negative 6. If you add them, do you get this?
You get negative 1.
Do you get positive 1, negative 1?
Negative.
So I should make this negative than this, eh? Yeah. Thank you. So when you multiply this and this, you'll get this, eh? But when you add them, you get oh, there you are. There you are.
Teacher, is it possible to get the pair before finding the sum and the product?
Nope, it's not possible. Now, you see there are calculators which can cheat, which can find these things, but unfortunately, there is a calculator which has FX 100 or FX 991. Do you have it here? You are the FX 991 here. Where did it?
FX 01.
FX 01, you cannot buy 991. Where is it? I saw an old calculator here.
It is
that calculator is the one I'm talking about. It does the work. It isn't the thinking. So we shall see that later maybe. Okay, let me have this again here. 2x squared minus 3x minus 30. Or what is the sum here? The sum is? That very true sum is 3. I doubt. Do you doubt like me? Negative 3. Product?
negative 60.
Negative 6. Oh, now you think. Which numbers, when you multiply, you get 30 negative, but when you add, you get negative 3. Of course, the easiest way to see, you can list down the factors of the product to be able to see, like factors of 6 are 1, 2, 3, and 6, not so? So within this you can foretell this. Even in factors of 30, you have 1, 2, 3, everything divided by 30. 5 also, 6.
That's 10.
10, 15, and 30. So you can just modify the signs, play with two numbers as you change their signs. So you can test the factors of 6, but that's being tiresome, see? Okay, what are the thought like you just begin testing the product. Which number do you multiply to get 60? Then you'll play with those. Which numbers do I multiply to get 60? Write pairs that give 60 here. Let's see.
4 and 15.
4, 15. What else? All of them?
We have 6 and 10.
6, 10. Any?
We have 5 and
12?
12, yes.
Again?
30.
2 and 30. Then 1 and 6 itself. So, now try to play with their signs. Which one would really play up with the sign very, very, very well? Play there. See. No, I hope my number there are decopied badly. Sorry, this. So, sorry. When the number does not exist, you can't receive.
Hey.
Yes. See, therefore, what gives 40? You have 1 and
4.
no.
And
140
220.
220
10.
410
5, 8.
58 only.
Yes.
So you play with the signs. Which possible numbers can you see nearing us 3?
5 and 8.
What can I put now? Which one is negative or both?
Negative 8.
Negative 8 should be biggest. Okay, negative 8 and 5. Yeah. Now. Let us factorize trinomials. Now, since you have known how to treat those things, now to factorize, we need this information here. See. Now.
Patience has made us to prove.
Say it again.
Patience that has not understood. You have understood. Anyone really will answer there. Look at this one. How many answers have you given?
So somebody said the statement that patience has not. Okay. Let us test it, the two people whether they said the truth or not. Okay, give us the sum here and the product.
The sum is 7.
The sum is 7.
The product is 12.
Product is 12. Then the pair?
Ruth, it's
Which two numbers give 12 on adding? I mean on adding give 7, but on multiplying give 12?
3 and 4.
3 and 4, wonderful. See, we know now she did not, they accused her of not having So factorizing, see, that's right. Factorizing trinomials. See, now the important note here is that the sum, see, the sum is replaced with the pair, see, of two numbers. Grouping is done and factorization. See, now factorize each completely. I'm starting with this itself here. So x squared plus 7x plus 12. Now I want somebody to really oh, that's right. And remember that I'm only going to factorize it 2, then we call in the participants. So now what is the sum? 7. Product? 12. Pair? Look here. This part here, 7, we replace 3 and look now. Look here. It will be x squared. Now where there is 7, put what? Plus 3x, then 4 is also positive. 4x, see? Then plus? 12. Oh. Then you conduct grouping, see? Because they are 4 terms. So, now what will we be having? X squared plus 3x plus 4x plus 12. Now look, what's common? X into x plus 3. Then plus, who is common here? 4 into x plus 3. Wonderful. So this and this is a common thing. So you'll have x plus 3 into x plus 4. That's right. Oh, the teacher is doing only 2. Could I factorize? There am I here. Part B is here. I've already landed on mine here. So what do I do? The sum is negative 3. Product? Negative 40. So you multiplied, not so? Yes. So pair? Negative 8 and 5. So look here. This is maintained, but where there is here I put this. Look now, 8 has a negative. Move with it. 8x 5 is positive. You don't follow this. I'm following the signs on this. See, then minus. So now group. See, 2x squared minus 8x group plus You see, I wanted it to have a funny form, but it is a good form for me. So for you are going to meet a funny form. So, what's see, this is 5x minus 20. So what's common?
X.
See, 2x. Oh, here remains
X
minus
4.
4 plus 5 into x minus
4.
There you go. There you go. So, what do you have? X minus 4 into 2x plus. Yeah, teacher, you're very wonderful. So, yes. Now, have you warmed up for these two before you got solving quadratic equations?
Yes.
Now, since you have mastered this, the solving of quadratic equations is just direct. So I'll also solve 2 only. See? That's right. That's right. That's right. So factorize completely. You have, let us call in their heads. That's 5x squared plus x minus 6. With that one, then you have x squared plus x minus 6. Oh, let me have 2 people there. Run here. Handle 1. See, you are ready? You are free. Please take over. You want to take over? Are you always ready? Run. There is no time. Run the dogs. That saying in Uganda called duka za mbwa.
Okay, working out this one, we have x squared plus x minus 6. So we first get the sum. The sum is 1. Then the product. Here there is a 1. So 1 times negative 6 to give us negative 6. So the pair what numbers do we multiply to get negative 6? And do we add to get 1? Negative 3 and I think it's not true. This should be positive 3 and negative 2, because this will give us 1 after adding and multiplying will still give us negative 6. So we shall have 8 squared plus 3x plus negative 2x minus 6. So we are going to group these and we are going to have x squared plus 3x plus a positive times a negative to give us a negative. So here we shall have negative 2x minus 6. So here what is common in this bracket? We have x plus 3 plus here we have we have 2. Yes, so here we shall have 3 minus 3, because 2 times 3 will give us 6. So here we shall have we have to make this expression the same as this one, so we shall have to make this one a negative. So we shall have a negative times a negative, giving us a positive, then a negative times this negative, positive, leaving us with that. So we shall have the common ones first, which is x plus 3 into x plus minus, because a positive times a negative gives us a negative.
Yeah, really, we needed to clap for her twice. Clap for her twice. Some did not clap twice. Come on, the last number. Thank you, Grace. Come on, guys. Come on. We have the last discussion called solving. Therefore, keep time. Yeah, we don't have time. Come on, guys. Don't fear. Yeah, we just thank those who are very, very hard to come. That's being hard-hearted. We love those hearts that are hard enough.
X squared plus x minus 6. We shall have to find the sum, which is 5 plus negative 6.
The sum is 1.
Then we shall have to find the product, which is 5 times negative 6.
Negative 30.
Then we shall have to find the pairs, and the pairs are
5 and negative 6. No, negative 5 and 6.
So 5x squared plus this x, we shall have to represent it by negative 5 x.
We don't do the plus sign, so it will be minus 5.
Will it be okay if we say 6x first?
And the order is okay.
Then minus 5x minus 6. So since they are now 4, we shall have to put them in brackets.
5x squared
Plus 6x into brackets minus 5x minus.
But that bracket doesn't have any common, so I group it like that. I think it's better if we bring 5x squared minus 5x. Then 6.
It is okay, even if she works that way, she should have to just think
So we shall have to find the common one in this bracket first, and that is x. So into brackets 5x plus 6 minus 5x minus 6. So this side we have 5x plus 6, and this side we have 5x minus 6. These ones are positives. This one is a positive, but this one is a negative. So we shall have to make it a positive. X 5 into brackets 5x plus 6 plus,
Yes.
plus 5x plus 6. So these two are the same, 5x plus 6, and also this side 5x plus 6. So it will give us 5x plus 6 and then x alone.
Excuse me.
Oh God.
Excuse me.
Thank you very much, Precious, for being hard and courageous. Sometimes the numbers are like eating very sour cassava. Yes, you have a suggestion?
Teacher, there where on that, no, the third class.
This one?
Yes. The negative times the negative gives you a positive. So
positive.
there's no need of changing the sign.
But my question is, from here, is she okay?
No.
For I know you wanted her to start with this. Any order will work, not so? Now, the issue is that here when handling, you see what she put out. You see what remained inside here? See, here there is a funny thing here. When you put a negative out, be careful that if you open back, it will go back. Does it go back already?
No.
No? So this, it's like you remove the negative and put it out. So every time inside remained positive. That was the only problem. Yeah. And that's what the only deeper thinking. But if she had gone the other way, she wouldn't have thought this way very much. See, now, since you put here a negative, I hope you are aware that there is a hidden one here. Not so?
Yes.
So which makes this one to be minus 1. But even if she had gone the other way, Grace wanted very much for her to say minus 5x. Did you want this? Plus 6. Then minus 6. Grace, did you want this?
Yes.
So that she should end up working with the 5 and 5 is common and 6 and 6 is common. So it would be easy. Not so? Yeah, now let's say 5x into what would remain? X minus 1. Then here you'd say 6 into x minus 1. Of course, this would be quite more direct than the brains that are here. So you see, anyway you will reach, but one is a hard way. Solving quadratic equations is our heading. But I'm impressed, you see, it is courage to come and work a number. You need to be really, you need to have encouraged yourself, not so. So Precious knows how to encourage herself. See? And I've been seeing Grace battling here so many times. I love that really, that heart of war, mathematical heart of war. So, solving quadratic. Now at this level class, we are only going to introduce one method. Methods there are 4. We are going to look at factorization method, the one we are discussing now only. Then you can keep researching method of completing squares. Just research on it, completing square. That will be senior 3 work, because listen, we are going to revisit these equations more in senior 3. See, for us at this level we stop there. Then there is a formula called Bulu. Those are all quadratic formula. Those who can run and read ahead, go ahead and read, since you are 1 year to senior 3. So then graphical method, which we'll discuss in senior 3. So using factorization to solve quadratic equation. I request that hot. You guys, you'll help me. I'm only going to discuss one number. So, I can discuss, probably 2. Solve. See. So 4x squared minus 12x plus 9 equal to 0. Now listen, when we say when an expression is an equation, it has equal what? Signs. An equation is an expression with equal signs. So we start again with finding the what? The sum. Okay, allow me to solve it from up here. See, what is the sum class? The product, help me here. Then the sum is 12. 12.
The product is 28.
28?
36.
36. Pair? Why is your sum wrong?
Negative 12.
12. See, which 2 numbers do you multiply? Okay, let us get first. Which numbers do you multiply to get 36?
9 times 4 and 36.
4 and 9, then?
136.
136 again?
66.
66. Okay, which of these can be manipulated to, when we add, we get negative 12, when we multiply? 66.
Yes.
Are you sure you add, you get negative?
Negative 6.
Okay, wonderful. So, what do? I work, of course, I factorize as usual, then reach the factorization step. So, move now. 4x squared, now both are negative, not so?
Yes.
Minus 6x minus 6x again, then plus 9 equals
0.
Look, group. 4x squared minus 6x, should I group with an additional subtraction? You can group with any. If you use subtraction back, you must be careful on the inside what happens. See, so who is common here?
2x.
2x. Yeah. What remains?
X minus.
Are you sure?
2x.
2x minus 3. What's common?
3.
3 into negative 2x
plus 3
plus 3 equal to 0, not so?
yes
You see that this bracket is differing by a sign, not so?
yes
So I'll modify, I'll put a negative out. You understand?
yes
Negative times a positive. So into 2x minus 3. So we now have 2x minus 3 into 2x minus. This, are you sure it is the same?
yes
Equal to what?
0
Now look here. We say either the first bracket is equal to what?
0
And we solve 2x minus 3 plus 3 is equal to plus. So 2x is equal to 3 out of 2 out of 2. X is equal to 3 out of. Or again the 2x minus 3 is equal to 0. Not so. 0 will receive the same what? So this one is by chance that the answer is the same. Don't say they will be the same. If there are two answers, you will just say x is equal to 3 out of 2, which has been what? Repeated. But this is by coincidence that my first number is given two similar answers, which I didn't want. But so you can get two values of x.
But excuse me. I was asking myself.
You're asking yourself?
Why is it that we only work upon the second bracket to make it the same bracket, to make it the same number as the first bracket? Why not the first bracket?
See, now it's not that we work on it, no? Now a student who started with a negative here will totally end with this step itself being similar. It's just that the way you move, you are moving through the number creates signs that have to be worked on. And in 4 terms, maybe let us accept your suggestion that we always work on the second bracket. It's just that in 4 terms, 2 brackets must look the hot. So now allow me.
Here is it here at the end of that question. Is it okay if we change it into a mixed fraction?
It is okay. One whole number, or even you say 1.5. Oh, I think you're okay there. Now this one is part B, factorize. See. Oh, that factorize 3x squared minus x minus 1. This is 2x. Hence, solve the equation 3x squared minus 2x minus 1 equal to 0. So class, permit me to finish my part, then I call in your part and we close. See? Now the thing said first do what?
Factorize.
See? 3x squared minus 2x minus 1. What is the sum? Guys, come on.
Negative 2.
Product.
Negative 3, positive, negative 3.
Then the pair. Which two numbers do you multiply to get negative 3 and when added is negative 2?
Negative 3. 1 and negative.
1 and negative? Wonderful. So we move now. 3x squared. Now you see 1 is positive. So I will say what? Plus 1x, which is x. See? Then minus 3x minus. Clear? Now we group 3x squared plus x. Now, you see, there are candidates there are students who might not even worry with the grouping. At this same stage, he factorizes direct. Look.
3 equals to 0.
Look, now I'm not going to group. I'm going to group, but in a funny way. Look. What's common here?
X.
X. So what remains?
3.
3. X plus
1.
Now here there is negative. I put a negative out. So I remain with
X.
A negative is out, remember, plus. So I will not bother with that step that I first group. When I say negative and a negative is a common, put the whole negative out, so terms inside will be positive. There you see, as we modify things, we become a bit more advanced. So what's common? 3 clear? No, here there is a mistake, class. Is the 3 really common? No, it's just a negative that was what?
Common.
So it's negative 1.
Yes.
So minus nothing is minus 1. So we have 3x plus 1 into x minus
1.
So now I've factorized. Then I'm going to answer the part called what? Hence. So hence, you just now get this, which is that 3x squared minus 2x minus 1 is 0. Look here. Look here. This part here is already
There.
this. So I put it here. Plus 1 into x minus 1 equal to 0. Then say either the first bracket plus 1 is equal to 0 and sort of 3x plus 1. Guys, are you okay?
Yes.
Minus 1. So 3x got negative 1 out of 3 out of 3. X is negative a third. Or the second bracket, x minus 1 is 0. X minus 1 plus 1 is 0 plus 1. So x gives us 1. Then you'll just say, therefore, x has 2 values, 1 or negative a third. So, yeah, I want to give you 2 numbers, or rather 1, and I let you to rest. Who is very ready?
All of us.
All of you are very ready. Who, you said you're all ready?
Yes, teacher.
Okay, sorry. Okay, somebody come on here. Solve this. Yeah, come on, and we close from there. Yes.
The sum is 5. The product is 2 times 2, which will give us 4. And the pair will be members.
What is the pair she wants assistance?
2 and 4 and 4 and 1 gives. So it will be 2x squared plus 1x plus 4x plus 2 is equal to 0. So we can group 2x squared plus 1x plus 4x plus. So we can, how do I call it?
Get the common.
Yeah, the HCF, which is x, right?
Yes.
Into 2
X
plus 1 plus, sorry, the common one, which is 2 into
2x
plus, sorry, 1 is equal to 0.
But
Yes?
is it in order for, okay, to put equals the other first side and again bring in equals the second time?
My math teacher told me I should put equal sign.
Continue, madam.
Okay. So we continue. Okay, now we are going.
X plus 1. X plus 2.
So it means we have to solve. Teacher, we're supposed to solve. Okay, so it will be
Because there
either.
is a 0.
It will be either
2x plus 1 is equal to 0. Plus 1 minus 1 is equals to negative 1. Out of 2 out of 2. X equals to negative 1 out of 2.
or
X plus 2 equals to 0. X plus 2 minus 2 equals to 0 minus 2.
sorry.
Negative 2. X is equal to
Therefore, x
is equal to negative 1 out of 2 or negative 2.
Yeah, thank you for closing us so perfectly. You'll be so good, so wonderful. Yeah, so perfect. Yeah. Now, let us close from here, class. That's how far we've gone. We started a broad topic called the Algebra 2. We visited the expansion of brackets. We visited the making subjects and building formulas, which I told you building formulas was in senior 1. Then we went to factorization, and finally we closed with solving quadratic equations. We meet in topic 7. Good luck. Maintain practice.